Okay, good morning. In this session, we are going to discuss about the design thinking based smart agriculture system. Yeah, we will start this question.
So the design thinking is a framework for solving an innovative approach using the 5 stages. So in our college, the design thinking is one of the backbone for all the procedures. So the design thinking concept includes 5 stages. First one is empathy, the second stage is define, the third is ideate, the fourth is prototype, and fifth is testing. So this empathy will be collecting the drawbacks and the problems from the end users. In the define will be altering the data that are needed for our project and the problem statement. So in this ideate, we'll be designing an ideate model for this problem. So in the prototype, we'll be creating a live model and we'll be testing it in the last stage.
Empathy, farmers are not monitoring the weather condition, when the rain is coming, when the rain is not coming. The farmer can't monitor the weather system, and we can't weather the water flow through the for agriculturing the plants and crops. So we need this system.
In different part, we used to collect from the users like farmers feedback like what are the needed to improve the smart agriculture systems like using weather monitoring systems like using sensors and collecting data. So by using smart agriculture system collecting data, we send to cloud and cloud will send the data to end-to-end gateway, and the gateway will use to process the wider wireless network for mobile using users laptop or mobile devices, so that user can able to turn on or off the lights of switches of motors whether the water is overflowing or not, so they can save their crops using smart agriculture system.
So the ideate path for the smart agriculture system is that first phase is IoT monitoring, where we'll be monitoring all the field data using sensors that are placed in the environments. So the next is news API, where we'll be getting a live API of news from all over the world regarding the agriculture. And the last is generative adversarial network. So we are mainly focusing on this generative adversarial network because the sensors can just read the data, but it cannot justify whether it is a stable state or an unstable state. So this generative adversarial network will have a regenerator and a combinator. So regenerator will produce a values, and the combinator will combine the values to maintain the accuracy of the level. So the most cases will be using this GAN technology. So the main sensors we'll be using here are soil moisture sensor, pH sensors for identification of the pesticide value and the nutrition content over the soil, and you will be using a water level sensor to identify the water level in the field.
So I'm going to tell about the testing part. So overall, the farmer to monitoring the smart agriculture system is useful of ideal part. So the different type of sensors like BIR and water monitoring systems and soil moisture systems. So which is connected to the node MCU to the clouds. So it will be useful for the farmer to monitor the in daily lives, and also to stay productive, and they also monitor day-to-day live related monitorings.
Design flow process that is included in this smart agriculture monitoring system is that firstly we collected the data from the farmers, so it is like an empathy we collected. So the main drawback was in smart irrigation system and monitoring the field values. So the farmers were not able to properly identify the weather conditions and the status of the field. So we came to a conclusion that we must make a solution for the irrigation system and the monitoring of the field sensors. So we created an ideate model. So this ideate model was integrated with an artificial intelligence neural network model, so that the efficiency of the system will be higher and accuracy and sensitivity will also be higher. So we have also integrated a hybrid approach model, so that the hybrid approach model will always give higher sensitivity and precision values. So in the prototype we have made a prototype using a simple hardware concept. So the main focus was it should be a cost reliable thing. So the farmers cannot afford more cost. So we have to design a model that is of less cost. So we have tested this in farmers' field. So the output was good. Thank you.